Yes. So Arduino, microcontroller as I told you. So this is an Atmega 328 microcontroller. So microcontroller is a device which can do a particular task at a time. Okay. It couldn't able to run a multiple task like our system does. Okay. System or computer does. It only do the only one code at a time. If you wanted to, if you made a code of on and offing the LED for once, it will do that only until you're uploading another program or removing the power supply from that. Okay, and here we can find a reset pin. It might be in different location. Don't worry about that. Okay, reset pins. If you wanted that your program should start from in between. Okay, in between it's executing. If you wanted to start from the beginning, you can press that button to make it to start from the beginning. All right. So yeah, what is analog pins and digital pins? So analog pins is the pins which can read the analog signals. So basically, what this analog signal is an any continuous signal for which the time varying feature of a signal is represented by other time varying quantity. For example, a temperature sensor. Okay, so temperature. What the temperature sensor will do, or simply take temperature of today's temperature. Now it will be 32 degree here. Okay, so 30 degree means the temperature should not be constant, right? So for morning it will be around 22 or 24 degrees Celsius. Around 11 o'clock it will be 28. In the middle of the day it will be 30, 32 like that. The same way in the evening it will be falls down, right? It varies with the time varying feature. So according to the time, the temperature values also varies. That like that only. The analog signals also varies according with the time varying quantity. Okay, so this varies in between 0 to 1024. Okay, and what is digital signal? So digital signal is a type of continuous signal that is representation of sequence of discrete value. Discrete means whether it will be high or low. That's it. It won't have any value in between. It will be or 0 or 1. 0 means low, 1 means high. The two values only will get high or low. Example, you can take it as a normal switch. So when you on the switch, the LED will light on. I mean, the light will on. If you off, it will goes off. That's it. That's the concept of digital signal. So summary of Arduino was number of digital pins 14, analog pins 6, GNDs was 3, power pins will be 5V, 3.3V. As I told you, 3 ways we can power up your Arduino, that is using the USB pin, power jack or external power jack pin, and VIN pin. So breadboard. Yeah. So a thin plastic board used to hold electronic components, okay, that are wired together. It has two types of connections, vertical, horizontal. As I told you, if you open that one, you can find the strip of metal in that one. So if you connect positive over here, the whole line will get positive. Okay. If you connect negative over here, the whole line will get negative. Here we are going to use LED. So what is LED is? LED is light emitting diode. L stands for light, E stands for emitting, D stands for diode. Okay, a light emitting diode. Okay, what is that actually? What it will do? Diode. The property of diode is it allows the current to flow in only one direction. Okay, you might make the LED glow with the battery. Okay, if you connect positive to the positive, negative to the negative, then only LED will glow. If you connect oppositely, the positive to the negative, negative to the positive, it won't glow. Okay, we doesn't know which one is positive and which one is negative, so we will just keep on the battery and check it out when it will be getting on like that. Okay, so how could you find that which is a positive leg, which is negative leg? I will tell that also. Okay. So LED is a light emitting diode, which is a semiconductor device, okay, that can emit a light when the electric current is passed through it. All right. So it has two pins, that is anode, cathode. Anode means positive, cathode means negative. If you take the LED in your hand, we need to check the leg size of it. Okay. One size will be bigger, one size will be smaller. The bigger size side is called as positive, that is anode. The smaller side is called as negative, that is cathode. All right. So anode, cathode, we understand. And if my LEDs both the legs are same, okay, I have cutted the leg size. How could you find in such a way, in such situation? So what you will do is inside the LED, okay, you can find two metal contact in it. One will be bigger, one will be smaller. The bigger side is positive. Sorry, bigger side is negative here, and the smaller side is positive. So bigger side is cathode, the smaller side is anode. Okay. So whereas the legs, the bigger side is positive, the smaller side is negative. Whereas inside the metal, the bigger side is negative and the smaller side is positive. Yeah. So this is a symbol of LED. So diode means this thing will be there. A light emitting diode means these things are there, like the arrows, the light emitting arrows. So now we are going to make the simple connection with the LED. Here I told you before that we are going to use the resistor. Resistor, it resists some amount of current. Okay. So there'll be so many ranges of resistor was there. I'm going to use 1 kilo ohms resistor. Okay. So first I'm going to place some materials. My Arduino. If you have any questions, you can ask in between. LED, resistor. Okay. So resistor doesn't have a terminals. Okay. The LED has a terminal that is positive and negative, whereas the resistor doesn't have a terminals. You can connect it anywhere. Okay. So this is the anode. This is the anode and this is the cathode. Cathode means negative, anode means positive. So I'm going to connect my resistor to the anode end. So yeah, I'm just rotating it like this. Okay. So yeah, first pin, the cathode should be connected to GND, right? So take it to the GND. So for our understanding, I'm just changing the color of this one, that is black. This is positive. Why I'm going to use resistor here? I can directly connect to the power, right? Then why I'm going to use this is the operating voltage of LED will be 1.5 to 5V. Okay. So if you give more, what will happen was it will burn out, or you can find the burning spell. So to avoid that, we'll be using the resistor here. So the output voltage of your Arduino Uno will be 5V only. So whatever device you are interfacing with the Arduino Uno, it should be 5V. If you're using the 12V device or something, we have to use additional device like relays, motor driver, like that. I'll teach you in our upcoming classes what are those and how to use that in our programming. Okay. Yeah. So yeah, I'm connecting the positive to the 5V. So see now, start simulation. Now your LED start to glow. So if I'm not using the resistor, what will happen? Just see this. I'm directly connecting to the resistor. Sorry, the LED. See here, you can find the burning image over here. To avoid this, we'll be using the resistor. Okay. So if you the connection, simple connection I show you with the positive and negative. Okay. Now I'm going to make my LED to on and off according to my application. So we might you might see the lights in our home, right? So it will automatically turn on and off. How it is happening? How we can make that? The serial lights. That I'm going to show you. So first take this pin. You can connect this pin to any digital pin. Why? Because why I'm going to use a digital pin? I can use the analog now. I'm not going to vary from the LED is a digital one only, because half or on. So I'm going to use the digital pins. Okay. So if I'm using any sensors, I'll be using the analog pins. All right. There are analog sensor. On that cases, we will be using the analog pins. So this is I'm going to on and off now. So I'm just using a digital pin here. You might ask me that why you're not using 0 and 1. Actually, 0 and 1 pin, especially for the transmitter and receiver. Okay, so if you're using any communication devices, in such cases we can use these pins. Okay, so unless we can go with the 2 from 2 to 13 pin. So I'm using the pin number 2 here. You can use 2, 3, 4, 5, 6, anything. And in the 13th pin, there is an inbuilt LED in our Arduino. That pin is connected. Okay. For example, this is a LED. This is the 13th pin. I'm just showing you 13th pin also in code. I show in both two code. I'm going to show you. One is with the block and another with the text code. So the skits are from 3rd to 8 data. So I'm just going to go with the block code first. So I'm going to clear the codes from here. Okay. First thing, set pin 0 to high. I'm going to make it to on by setting it to be on. On means high. Off means low. Okay. So I'm going to on and off which pin? Pin number 2. So make it has to be 2. So first I'm going to on the LED. Again, I'm going to off the LED. So pin number 2 to be low. All right. So to check this, go to start simulation and check this. You might find that the LED is lightly glowing, but it's not off and on. Do you know why? The process is executing very fastly. Okay. So we need to slow down that. How could you slow down the process? By giving some delay over there. Okay. So delay is control. Wait for 1 second. Here also wait for 1 second. So the LED should on for 1 second and goes off for 1 second. Okay. Yeah. So to make this process to execute continuously, we need to give all these commands inside the forever loop. So forever means it will do continuously. Start simulation. If I wanted to on and off my LED faster, what am I supposed to do here? Any guess? Any guess? Anyone can tell me that what I can do to make it to on and off faster? Idea? Any guess? Fine. So we need to reduce the weight here. That is, if I'm giving 0.5, what happens? It's a little bit quicker, right? Than before. So if I wanted to make it very faster, 0.2. 0.2. Okay. So now I'm going to teach you the text code. I'm just going to change this to be a text. So in text code, we are going to use C++ coding here over here. So how we are going to do the code? Here there are two main functions. One is void setup and one is void loop. So whatever the command you're giving inside the void setup will execute for once. Okay. And whatever the commands you're going to give inside the void loop, it's going to do it continuously. Okay. So here, I'm going to create a variable here, integer, because 1, 2, 3 only, that is 0 or 1 will be an integer value. So I'm going to create a variable integer. Variable is nothing but it's example, you can take it as a jar. Okay. So in a jar, you're going to store some value in it. Your mama is storing some biscuits or chocolate, like that only. Okay. Here I'm going to store some value. I'm going to give that variable name as A. Okay, A equal to where I'm going to get this. What I'm going to store is the LED on off. So LED is connected to pin number 2. 2. That's it. So semicolon is important here. So to completing that statement, we need to give semicolon. And then, so initialization command I need to give here. What LED is an input device or output device? LED is an output device. All the sensors are input device. All the actuators, that is light, motor, these are the actuators. Those are the output device. So LED is an output device. Pin, M will be capital, pin mode. Pin mode 2, output. So see here, first pin number is 2. Mode will be an output mode. So I just define over here. So I need to on and off for the second. So on means I'm going to set it. How could I set it? Is the command for setting it was digital right. The W should be capital over here. Right. The digital right. Pin number 2, high. Close the bracket and semicolon. Okay. If I wanted to low the LED, digital right 2, low, semicolon. We need to give delay in between. Delay 1000. So the delay is nothing but some wait. Okay, we are delaying the process. So delay 1000. So see now. You might ask me that why you give 1000 here? We need to give 1 second, na? So here, whatever the seconds you're giving here, it will take it as a microsecond. So 1000 microseconds will be milliseconds equal to 1 second. So that only I'm given 1000. Any doubts as of now? Ask me a doubt if you have. Doubts? So I'm going to show you with 2 LEDs now. I told you one more thing also, na? That is, it has an inbuilt LED in our microcontroller itself. So could you make it to on? I'm just showing you that. So I'm not going to give any extra LEDs. So what I'm going to do is I'm going to change the pin number to be 13. Pin number 13 high and pin number 13 low. So see now. You can see the LED is turning on for once again and going off once again. Okay. So now I'm going to connect 2 LEDs. Stop simulating. One more LED. One more system. So we are going to see use a common connection over here. Take a GND. Make a comment. So this whole line will get a negative GND. Take the LED, connect it over here. This is the LED. So resistor. I'm going to connect the resistor to the negative end, that is to the cathode. So one end of the cathode should be over here and another should be on this. So we have connected the common ground. The positive of the LED should be connected to pin number 2. You can connect to any pins, but I'm going to connect it to the 2 and 3. Yeah. So first I'm going to on both the LED at a time. Set pin 0 to be high, that is 2 to be high, delay, okay. Set pin 2 to be low, wait for 1 second. Same process has to be repeat for next LED. That is first LED 3 should be high and wait for 1 second. Three should be low and wait for 1 second. Now first LED will turn on and off. Second will turn off and turn off. On, off, 3 on, off, 2 on, off, 3 on, off. If you want both the things to be on at the same time, I need to remove the weight in between. See, all the high should be on one place. Weight, low over here. First, both the LED will turn on. Next, both of it will go off. Like this, we can on and off so many LEDs here. The maximum of LEDs which we can connect over here will be 8 LEDs. Okay, with different signals, we can turn on off. If you wanted to turn off 12 LEDs or 16 LEDs with 2 to LED signal, then it will be possible with this single Arduino itself. Any doubts till now? If you have, you can post the doubts. So shall I give you the activity to be practiced in your home? Because next class will be on next week, right? So in between you'll be free. So we can try with one activity. So you just make and show me on next class. So you can connect 3 LEDs and make it to on and off one after one, like a traffic light LEDs. Okay, you can use different colors. Ma'am, how can I change the colors of the LED? Here only one color is there now. Yes, you can change the LED color here. That is by clicking the color. Blue, red, green, and yellow. 3 colors. Okay, so you're going to try with that. So when you're waiting in the traffic jam, you can find that 3 lights are glowing now. how it is happening. The same way you're going to create and show me. Okay, you try by your own. Okay, if it is not working, also not an issue. I will teach you next class also. I will revise everything once again and then I can move on to the next part. Okay, this is clear. So, okay, ma'am, you just showed in scratch code now. So, how could we do with the text code? So I'm just going to change the code type here. Establish simulation. Text. So I'm going to create two variables here. Int LED1 is equal to 2. Sorry. Int LED2 is equal to 3. Okay. So pin mode 2, comma output, because both are the output devices. So I'm making it as to be output. Pin mode 3, comma output. So I want to on the first LED and after second LED. Digital write 2, comma high. Delay 1000. Digital write 2, comma low. Delay 1000. Digital write 3, comma high. Delay 1000. Digital write 3, comma low. So now the first LED will turn on for 1 second and goes off for 1 second, and the second one will on and off for 1 second. So here I just forgot to give W in capital, so that shows the error. So these are the predefined function. In the predefined function, we couldn't able to change that one. If you do that one, it will show you the syntax error. Even in pin mode also, if you make the M in a small letter, it will show you the error. And even output small letter. See? It shows error in this one. The red icon shows that error. Pin mode M is here. You can read that one error. Output was not declared in this scope. So output we need to correct. So output should be capital. And then pin mode was not declared in the scope. So pin mode, other things was correct. Then M should be on capital. Even for this high, low also. To give small letter high, it won't accept this. We need to give capital 1. If you wanted to on both the LEDs at the same time, we need to give the digital write 2 high and 3 high, and like this, and relay should be here. Both the LEDs on, on, off, on, off. Even you can make that to be on and off fastly. That is, I'm just going to give you 500. See, on is very less, or off is very high. So off time will be reduced to 200. Let's see the difference. Clear? Any doubts? You can ask me doubts now. Have any doubts? You can ask me. The coding part or the connection part. Even I'm not understanding what is robot and robotics. Anything else you can ask. Thing. You can interact with me. Then only you can understand the concepts of this. Next session also we are going to do one more interesting project. Okay, so next class I'm going to teach you that how we can interface the 6 to 7 LEDs and how to make different patterns and how to make letters to be appear on your LED connections, like that we are going to see. Doubts? So future of robotics. So in future there will be so many robots we're going to rule actually. So thing was, why I supposed to read this robotics as a topic, or why I need to attend this class, or I'm going to join this class. You might have a big question, right? Why? Because everything around our world is made up of the STEM field. Okay, so after your schooling you're going to work, right? So even in your schoolings also, while learning something, or when you go somewhere, you're experiencing something like while you're walking, how you get a grip from your floor. Okay, so if you're work on oil, what will happen? What is happening over there? Everything around that is science only. So we are going to learn the science in practical way. So STEM subject we are going to cover through this robotics. That is, STEM means science, technology, engineering, mathematics. Okay, science means everything around us. So while walking, as I told you, we use a frictional force. So if you don't have a friction between us and the floor, you will skip it out. Okay, you will skip down. That's what you won't walk on a oil or some slippery surfaces, right? So that only in our slippers and all, they given some interesting or some um, kind of designs on the backside of the footwears. Have you noticed it? Okay, okay. And the same way, while you're climbing the bikes to your home, we'll be using the some slider thing on your home, right? So even we have a we might kept um steps, but still we use the slope on it. So slope is nothing but it's actually a, what is it? Have you heard about it? It's also a type of simple machine. Okay, so every day it's related with the science. Everything related with the science. From the morning we are getting the milk pocket till the evening when you're sleeping. Also we are using the mathematical concepts and the science concepts that we are going to experience by doing the robotic projects here. Okay, so engineering means you're going to construct, design or construct or design some robots over in our classes. Okay, then technology is what technology we can implement to the system which we are going to work. So if I'm using the, if I'm going to make the doorbell system, doorbell means when my doorbell has to start, I'm going to make automatic doorbell. So when the door has to ring the bell, when somebody is standing in front of my door only is supposed to on. So for that purpose, what you are going to fix it on the front of a door? We are going to keep a sensor. So what kind of sensor we can keep? So while entering into the malls, the doors of malls open automatically opens the door. How it is happening? So have you think about that? How it is happening? It's because of these sensors. That is an PIS sensor which is kept over there. That is that sensor can sense the IR radiation from the environment. That human beings actually eliminates the IR radiation naturally. Okay, so all the living beings will eliminate that one. If that levels reaches to that sensor, it will sense it and automatically open the doors. Not only for a human. If the animals, the bigger animals also trying to enter that door, it will automatically open. It doesn't have an AI feature. So if you implement the AI feature, then it will sense or it will record the person who's entering into the wall, everything into the mall, and everything it will be recorded and stored in a data. Okay, there's AI powered robots, and human robot collaboration will be like yeah, already started to do that one in industries, but not here. Okay, anything else? Any doubts? Any questions you can ask me. If you have already any idea with the robotics also, you can tell. Thank any doubts or something. You can ask me freely. Don't worry about anything. I will clear your doubts. Even it might be a very silly doubt also. It will be fine. I want you should understand the concept and you should learn something new today. Yes, any doubts? No?
Hello, everyone. Thank you, attendees, for attending the workshop. And I would like to thank Divya ma'am for the beautiful session today. Uh, Attendees, you can join the next class next Sunday, same time. Okay, and you can bring your friends, and if anyone wants to learn robotics, then they can join as well. You can share the links to register this workshop. Okay, thank you very much. Thank you, everyone. We are, ending this session today, and see you in the next session. Thank you.